Hello everyone, welcome to part 2 of algebra. I have two questions for you today. Question 1, solve for x. We are told x is a positive number and we're told that x is a real number. So we have x equals square root of 12 plus square root of 12 plus square root of 12 plus square root of 12. Now we're required to find the value of x, and yet they have already given us the value of x. This means this expression here simplifies to some number. So how do we go about this? Here is how we do it. Answer. So this is question 1. A. Let's get the question down. X is equal to square root of 12 plus 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 do. That means square root of 12 continues infinitely. So we know that x is positive. That should be noted right at the beginning. So to solve this kind of question involving a square root sign like this, we have to square both sides. So squaring on the left hand side, this is what we get, and we have to square the right hand side as well. Square root of 12 plus 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 do. Squaring the right hand side allows us to get rid of the first square root sign. So on the left side you have x squared, on the right side you have 12 plus square root of 12 plus square root of 12 plus square root of 12. The three dots allow me to add another square root of 12 because I can continue adding infinitely. Now, looking at this expression here, it is absolutely important and critical that you notice that this expression here is exactly equal to that expression right at the beginning. And what is this expression equal to? It is actually equal to x. So I can get rid of this and replace it with x as follows. X squared is equal to 12 plus x. Notice now that this is a very simple quadratic equation, which writing in standard form produces the following equation. Subtracting 12 from both sides and subtracting x from both sides gives us this equation, which can easily be factorized into x minus 4 and then x plus 3. This whole thing is equal to 0. At this stage, we know this means either x minus 4 is equal to 0 or x plus 3 is equal to 0. This gives us x equals 4 or x is equal to minus 3. But remember now, we said x must be positive, and that's according to the instruction given in the question at the beginning there, right at the beginning. And therefore, we have to discard this solution. This means that x is actually equal to 4, and that is our solution for question 1a. Now let's move to question 1b. Question 1b, another intriguing question in algebra. There it is. It says solve for x. Remember, right at the beginning there, we are told to solve for x. right here. Solve for x. Solve for x. And so how do we go about this? X to the power x to the power x to the power x, and you can continue. The three dots are saying you don't have to stop. And again, we are told that x is positive and x is a real number. And the instruction says leave your answer in insert form. So watch what I'm going to do now to tackle this one. So the answer, and that's for question 1, B. Let's get the question down. And this is equal to 2. Now watch my next step. Step number 2, I'm going to add 1x at the top there. The three dots allow me to do that, equals 2. Now notice something here, that this expression here is exactly that one. And what is this equal to? Is equal to 2. So I can replace that with 2, which changes my equation to x power 2 is equal to 2. At this stage, we have to take square root on both sides. So square root of x power 2, this should be equal to plus or minus, it's a quadratic equation. We have to put plus or minus on the right hand side as we take the square root on the right hand side. Now on the left hand side, this square root sign cancels that 2 there, and we have x is equal to, but remember, x is positive. X is supposed to be greater than 0 right there. And so this means I have to discard the negative root of 2. I must take the positive root of 2. And this then is my solution to question number 1b. Now let's move to question number 2. Question number 2, we have question 2a, still on algebra. Question 2a says, given that AC minus A minus B is equal to 0, and we are told that A, B, C are all real numbers, but there's additional information. A is greater than 0 and B is also greater than 0. What are we required to prove? We're required to prove that C is greater than 0. How do we go about this? Here is how we go about it. Question number 2a. Given information, AC minus A minus B is equal to 0. Naturally, when you are told to prove that C is greater than 0, it's going to be necessary for us to make C subject to formula here. So AC is equal to, add A and B on both sides. You're going to get A plus B on the right hand side. Dividing throughout by A, we're allowed to do that because A is positive, is greater than 0. A is not 0, is greater than 0. Division by 0 is not allowed. In this case, we have the freedom to divide by A. So AC over A is equal to A over A plus B over A. There is your term-wise division there. On the left-hand side, you have C is equal to 1 plus B over A. Now remember, A and B are both positive. So the quotient of two positive numbers is positive. That means whatever you get here, when you add to 1, this whole thing should be greater than 1. But what is this equal to? This is equal to C. So I can conclude here that C is greater than 1. Now, if C is greater than 1, we're required to prove that C is greater than 0. So any number that is bigger than 1 is automatically bigger than 0. So therefore, we can comfortably say that C is greater than 0, and that is the end of our proof. Right. Now let's move to the last one. That's 2b. Question number 2b. Here it is. Yet again, we're required to prove something here. For those of you that are doing grade 12 physical sciences, you remember that this is coming actually from what we call Doppler effect. We will not discuss Doppler effect in this video, but the coming videos will be able to address the concept of Doppler effect as well. So how do we go about this? We're again told that F sub L is equal to V plus VL over V, all multiplied by F sub S. And we are told that all these quantities are greater than 0. All of them are positive. So how do we prove that FL is greater than Fs? Here is how we do it. Question 2b. Let's get the question down. V plus VL over V times Fs. Now, a little trick here. Let's divide throughout by Fs. Dividing by Fs throughout, we get Fl over Fs. This should give us V plus VL over V. Doing term-wise division here, we get V over V plus VL over V. Remember, this is FL over Fs. We're still saying FL over Fs is equal to, this is 1 plus VL over V. Yet again, like the previous example 2a, both VL and V are positive numbers or quantities, and therefore the quotient of two positive numbers must be positive. And therefore, whatever we get here, when we add to 1, obviously this is a number greater than 0. So when we add to 1, the whole of this should be greater than 1. And if the whole of this is greater than 1, and what is this? This is actually FL over Fs. So we now are saying FL all over Fs is greater than 1. And if you multiply both sides by Fs here, you're going to get FL is actually greater than Fs, which is what we were required to prove, and that's the end of our proof right there. This brings to the end of this short video on intriguing questions in Algebra Part 2. See you in the next video.